The morning of October 2nd, 1944, Yokosuka Naval Air Technical Arsenal, 30 miles south of Tokyo. Lieutenant Commander Takahide Aioi stands before an aircraft that, until 3 weeks ago, was trying to kill Japanese pilots over the Philippine Sea. The Grumman F6F Hellcat sits on the tarmac like a predator at rest. Its dark blue paint is scarred with bullet holes, evidence of the dogfight that brought it down near Saipan. American markings have been hastily covered with Japanese Hinomaru roundels, but this does nothing to disguise its foreign nature. Everything about this machine is different. The massive engine cowling, the thick wings, the brutal functionality of its design. Where Japanese fighters are built with the elegant efficiency of a katana, this aircraft resembles a warhammer. Aioi has been a test pilot for 6 years. He has flown everything from obsolete biplanes to experimental prototypes. But climbing into this cockpit fills him with an emotion he rarely experiences. Dread. Not fear of the aircraft itself, but fear of what understanding it will mean. Behind him, a dozen engineers and fellow pilots watch in silence. They have spent weeks preparing for this moment, dismantling this Hellcat piece by piece, measuring every component, analyzing every system. What they discovered has shaken them. Now Aioi will fly it, and in doing so, he will experience firsthand why Japanese pilots are dying at catastrophic rates across the Pacific. The kill ratio has become unspeakable. 19 American victories for every single Japanese fighter destroyed. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The cockpit is enormous compared to what Aioi is accustomed to, designed for larger American pilots. He stuffs towels behind his back to reach the rudder pedals properly. The instrument panel is labelled entirely in English, but after weeks of study, he knows what each gauge represents. More importantly, he knows what they will tell him. Because they have measured this aircraft's capabilities with scientific precision, and the numbers terrify them. The Pratt and Whitney R-2800 double wasp engine starts with a roar that seems to shake the entire flight line. 2,000 horsepower, more than double the power of his beloved Zero. The whole aircraft vibrates with barely contained energy, like a leashed animal straining to run. He advances the throttle and begins his taxi. Within the hour, he will write a report that his superiors will immediately classify and suppress. Because what he is about to learn is not merely a tactical problem or an engineering challenge. It is an indictment of everything the Imperial Japanese Navy has believed about air combat for the past decade. But to understand how Japan's finest aeronautical minds arrived at this devastating conclusion, and why their discovery came far too late to matter, we must return to a time when the Zero seemed invincible and Japanese naval aviation dominated the Pacific sky. December 7th, 1941. Pearl Harbor. The A6M Zero fighter swept through the morning sky over Oahu like nothing American pilots had ever encountered. In the hands of Japan's superbly trained naval aviators, it performed maneuvers that seemed to defy physics, turning inside American P-40 Warhawks with contemptuous ease, climbing away from pursuing aircraft as if they were standing still, executing victory rolls that demonstrated not just mechanical superiority, but absolute confidence. The numbers from those early months told an unambiguous story. At the Battle of the Coral Sea, in May of 1942, Zero pilots claimed 35 Allied aircraft destroyed for the loss of only 3 Zeros. Over Darwin, Australia, the kill ratios were even more lopsided. In the skies above the Philippines, over Java, across the vast Pacific theatre, the Zero dominated with such thoroughness that Allied pilots began to believe it was unbeatable. Takahide Aioi watched these victories from a unique vantage point. He was neither a frontline combat pilot nor a desk-bound bureaucrat. He occupied the space between a graduate of the Imperial Japanese Naval Academy, who had trained as both a pilot and an aeronautical engineer. This combination was rare and valuable. He could fly experimental aircraft to their limits, and then explain in precise technical language why they behaved as they did. At Yokosuka Naval Air Technical Arsenal, Aoi and his team had been testing the Zero since 1940. They understood its design philosophy intimately. The aircraft was the brainchild of Jiro Horikoshi, a brilliant engineer who had made one revolutionary decision: sacrifice everything for performance. Every gram of unnecessary weight was eliminated. No armor plating behind the pilot's seat. No self-sealing fuel tanks. Minimum ammunition load. The airframe itself was built to the absolute minimum structural strength required for combat maneuvers. This philosophy worked brilliantly as long as you did not get hit. The Zero could execute turning circles so tight that American pilots initially refused to believe the intelligence reports. It could climb to 20,000 feet faster than virtually anything in the Allied inventory. Its range was so extraordinary, nearly 2,000 miles, with external drop tanks, that American analysts initially concluded the Zeros must be operating from secret bases closer to the combat zones. The alternative, that a single-engine fighter could fly such distances, seemed impossible. In early 1942, Aoi traveled aboard the carrier Akagi as an observer, sent to evaluate the Zero's combat performance under actual battle conditions. What he witnessed exceeded even optimistic predictions. He watched Chief Petty Officer Saburo Sakai, already an ace, shoot down two P-40 Warhawks in the span of 3 minutes. The American fighters were not incompetent, they were simply outclassed in every dimension of performance that mattered in a dogfight. But even in those heady days of victory, Aoi noticed something that troubled him. He examined the wreckage of shot-down American aircraft whenever possible. The P-40s and F-4F Wildcats were heavier than Japanese fighters, much heavier. They had armor plating protecting the pilot. Their fuel tanks were self-sealing, lined with rubber that would swell when punctured, preventing catastrophic fuel leaks. They carried more guns and more ammunition. The Americans were building fighters designed to absorb damage and keep fighting. The Japanese were building fighters designed to never be hit in the first place. These represented two fundamentally different philosophies of air combat, and somewhere in the back of his mind, Aoi wondered, what would happen when Japanese pilots faced an enemy who refused to fight on Japanese terms? Yokosuka Naval Air Technical Arsenal existed in a world of contradictions. The facility itself was impressive, sprawling across several square miles south of Tokyo. It housed wind tunnels, engine test stands, workshops, and multiple airfields. This was where Japan's military aviation technology was pushed forward, where prototypes were evaluated, where the theories of aeronautical engineers met the reality of aluminum and steel. Aoi's team included some of the finest technical minds in Japanese naval aviation. Commander Masatake Okumiya was a tactical analyst whose understanding of air combat doctrine was encyclopedic. Lieutenant Yoshio Shiga had flown at Pearl Harbor and Midway before transitioning to test work. A dozen civilian engineers from Mitsubishi and Nakajima aircraft companies rotated through, bringing expertise from the companies actually building Japan's warplanes. The work culture combined world-class engineering with a peculiarly Japanese blind spot. On the technical level, Japanese aeronautical engineering was genuinely excellent. The Zero itself proved this. It was a masterpiece of weight reduction and aerodynamic efficiency. Japanese engineers had pioneered construction techniques that Western designers were only beginning to understand. Every rivet was countersunk flush with the skin. Every surface was polished to reduce drag. Every component was optimized for minimum weight. But the engineering culture existed within a larger military culture that valued subjective qualities, fighting spirit, warrior determination, willingness to sacrifice sometimes more highly than objective technical analysis. This created a dangerous dynamic. Battlefield reports that contradicted prevailing narratives were sometimes dismissed. Pilots who suggested that American equipment might possess certain advantages could find themselves questioned not about their technical observations but about their fighting spirit. The term was seishin, a concept deeply embedded in Japanese military tradition, referring to the spiritual strength and warrior resolve that could supposedly overcome material disadvantages. It was the modern expression of samurai philosophy, adapted for 20th century industrial warfare. Aoi saw this tension manifest in countless small ways. When Commander Okumiya presented intelligence analysis about American industrial capacity, the staggering production numbers coming from factories across the United States, some officers would respond not with strategic adjustments but with assertions about Japanese spiritual superiority. When pilots reported that American aircraft were becoming harder to shoot down, certain commanders suggested this meant Japanese pilots needed better marksmanship training, not better aircraft. The engineers existed in an awkward position. They dealt with objective reality. An aircraft's maximum speed could be measured. Its turning radius could be calculated. Its structural strength could be tested. These were not matters of opinion or morale, but they served a military establishment that sometimes treated engineering limitations as problems of insufficient determination. Still, in early 1942, this tension did not seem critical. Japan was winning, the Zero dominated. The combined fleet controlled vast stretches of the Pacific. There was time, or so it seemed, to develop the next generation of fighters. The J-2M Raiden Interceptor was in development. The N-1 KJ Shiden showed promise. Japanese engineers were confident they could maintain their technological edge. That confidence shattered at Midway. June 4th through 7th, 1942, the Battle of Midway. Aoi was not present at the battle itself. Test pilots did not fly combat missions, but he was at Yokosuka when the survivors limped home. The numbers were catastrophic. 4 fleet carriers lost: Akagi, Kaga, Soryu, Hiryu, the core of Japan's carrier-striking power, sunk in the span of a single day. More than 300 aircraft destroyed. Hundreds of pilots died, including many of the most experienced carrier aviators in the entire Imperial Navy. But it was the survivor reports that chilled Aoi to his core. Lieutenant Shiga barely escaped with his life. When he returned to Yokosuka, Aoi found him in the officers' mess one evening, staring into a cup of sake with the 1,000-yard stare of a man who had seen something that fundamentally changed him. "The American dive bombers came through everything we threw at them," Shiga said quietly. "We shot them up. I saw bullets hitting, saw pieces flying off the wings and fuselage, and they kept coming. They kept coming, and they dropped their bombs accurately, and even then, some of them flew away afterward." "Their aircraft are armoured?" Aoi asked, though he already suspected the answer. "Like flying tanks," Shiga confirmed. "The Dauntless, that is what they call it. It is slower than our carrier bombers, heavier, less manoeuvrable, but it can absorb punishment that would destroy our aircraft 10 times over. We learned this the hard way." Another pilot, Lieutenant Junior Grade Haruo Yoshino, added his own observations. "And their fighters, the Wildcats, they will not dogfight anymore. They have learned. They dive in pairs, make one high-speed pass with all their guns firing, then dive away before we can turn to engage them. Over and over, they are using their advantages in speed and firepower. They refuse to let us use our advantages in turning performance." Aoi listened carefully. He was hearing something profound. The Americans were adapting. They had analyzed Zero's strengths and weaknesses. They were developing tactics and possibly new aircraft specifically designed to counter Japanese advantages. More concerning intelligence arrived over the following weeks. In the Aleutian Islands, American forces had recovered a nearly intact Zero from a crash site. The pilot, Petty, Officer Tadayoshi Koga, had been killed, but his aircraft had made a relatively gentle crash landing in soft tundra. The Americans would dismantle it, test fly it, understand every detail of its performance envelope. Aoi knew exactly what this meant. Every advantage the Zero held through mystery and reputation would evaporate. American pilots would train against the captured Zero, learning its exact limitations. American engineers would study its construction and design countermeasures. He wrote a detailed report recommending that the Navy prioritize development of next-generation fighters with more powerful engines, better armor protection, greater firepower, and more robust structure, even if it meant sacrificing some of the Zero's legendary maneuverability. The report travelled up the chain of command. The response was lukewarm. Yes, development would continue on improved fighters, but the Zero was still achieving excellent results in most engagements. Losses at Midway were attributed to tactical surprise and operational bad luck, not fundamental technical inferiority. What Japanese pilots needed was better tactics, better intelligence, better coordination, not an entirely new aircraft philosophy. Besides, there was a practical constraint that nobody wanted to acknowledge openly. Japan's industrial capacity was already strained. Even if designers wanted to build heavier, more powerful fighters immediately, the engines did not exist. Japan's most powerful production engine was the 1130 horsepower Sakai that powered the Zero. Intelligence reports indicated American engines were already producing 1700 horsepower, 1850 horsepower. Rumors spoke of engines approaching 2000 horsepower. Aoi did mathematics. If American fighters had twice the engine power of Japanese fighters, they could carry twice the armor and twice the ammunition and still maintain similar flight performance. The implications were deeply troubling, but it was still 1942. Japan held a vast Pacific perimeter stretching from the Aleutians to the Solomon Islands, from Wake Island to Burma. There was time, everyone believed there was time to address these emerging problems. The Zero was still feared throughout the Pacific theater. Pilot quality remained high. Japanese naval aviation still controlled the sky in most engagements. Aoi returned to his test work at Yokosuka, but the unease never left him. He had seen enough to understand. The Americans were learning and adapting faster than Japan could respond. By early 1943, intelligence reports arriving at Yokosuka began painting an alarming picture of American industrial mobilization. The numbers seemed almost incomprehensible. American aircraft production had reached 8,000 aircraft per month, then 10,000. By 1944, the figure would exceed 15,000 aircraft monthly. Meanwhile, Japanese production, peaked at approximately 2,500 aircraft per month, achieved only by straining the entire industrial economy to its breaking point. But quantity was not the only concern. Quality was improving dramatically as well. In August of 1943, Aoi received an intelligence summary that made him request an immediate meeting with his commanding officer. American forces had captured several Japanese airfields in the Solomon Islands. The intelligence assessment included detailed analysis of aircraft found there, and more significantly, included reconnaissance photographs of a new American fighter that had begun appearing in combat, the F6F Hellcat. Aoi studied the photographs with growing concern. The Hellcat was large, noticeably bigger than the Zero or even the F4F Wildcat it was apparently replacing. The engine cowling was massive, suggesting enormous power. The wings were thick and sturdy, with 6 gun ports clearly visible. Intelligence indicated these were 50 caliber machine guns, 6 of them, compared to the Zero's 2 20mm cannons and 2 7.7mm machine guns. But what struck Aoi most forcefully was the philosophy evident in the design. This was not an aircraft built for elegance or maximum maneuverability. This was built for a specific purpose, to kill Zeros and survive the encounter. The first combat reports arrived in September of 1943. At Marcus Island, Hellcats encountered Zero units and achieved a kill ratio of 10-1 in their favor. At Tarawa in November, it was 12-1. In the Marshall Islands campaign, 15-1. The pattern was clear and devastating. The Hellcat was faster than the Zero, not dramatically faster, but enough to matter. It could not outturn the Zero, but Hellcat pilots did not try. They used tactics called boom and zoom, dive from superior altitude, fire a devastating burst from 6 heavy machine guns during a single high-speed pass, then use superior power and speed to climb back to altitude before the Zero could react. And when Zero pilots did manage to score hits on Hellcats, the American aircraft kept flying. They had armor plating protecting the pilot. They had self-sealing fuel tanks that did not explode when bullets pierced them. They could absorb battle damage that would destroy a Zero outright and still make it home to their carrier. Lieutenant Shiga, now stationed at Rabaul, sent a letter back to Aoi that autumn. The letter was frank in a way official reports never were. "We are fighting a different war now. The Americans have learned everything about the Zero, how to avoid our strengths and exploit our weaknesses. Meanwhile, we are still flying the same aircraft with the same tactics, and they are killing us systematically. Last week, I scored 4 direct hits on a Hellcat. I saw the bullet strikes, saw smoke trailing from the engine. The pilot simply rolled away and continued fighting. 2 days later, one of our most experienced pilots, Chief Petty Officer Nishizawa, had his Zero riddled by a single burst from a Hellcat. He crash-landed and burned to death before we could reach him. This is the reality we face now." Aoi brought these accumulating reports to his commanding officer. He proposed a formal study: acquire a captured Hellcat if possible, and conduct systematic testing to understand exactly what advantages it possessed and how Japanese tactics and aircraft design needed to evolve in response. The response was bureaucratic deflection. Captured enemy aircraft were rare and extremely valuable. Testing would be expensive and time-consuming. Besides, new Japanese fighters were already in development, the J-2M Raiden, the N-1 KJ Shiden, that would address these problems when they entered service. But Aoi knew these new fighters were experiencing severe development problems. Engine reliability issues plagued both designs. Production was delayed repeatedly, and even when they did enter service, they would not have the engine power to truly match American aircraft on equal terms. Throughout late 1943 and into 1944, Aoi continued compiling every available piece of intelligence about the Hellcat. He interviewed every returning pilot who had fought against them. He built a comprehensive dossier. The picture that emerged was sobering. According to the best available intelligence and pilot testimony, the Hellcat's R-2800 engine produced approximately 2,000 horsepower, nearly double the Zero's 1,130 horsepower. Maximum speed was approximately 380 miles per hour compared to the Zero's 350 miles per hour. Despite being much heavier, the Hellcat matched or exceeded the Zero's climb rate due to its massive power advantage. 650 caliber machine guns delivered approximately 900 rounds per minute of combined fire, each round carrying far more kinetic energy than the Zero's smaller caliber weapons. The Hellcat could absorb 10 to 15 times more battle damage than a Zero and remain flyable, and it could dive at speeds exceeding 450 miles per hour without structural failure, whereas the Zero's lightweight construction limited safe diving speed to approximately 350 miles per hour. Every single performance metric except turning radius favored the Hellcat, and turning radius no longer mattered because American pilots simply refused to engage in turning combat with Zeros. The most damning statistic came from systematic analysis of combat reports across multiple theaters. When Zero units engaged Hellcats in air-to-air combat, the kill ratio had stabilized at approximately 13-1 in favor of the Hellcat. For every Hellcat shot down, 13 Zeros were destroyed. This was not a tactical problem that could be solved with better training or revised doctrine. This was a technological chasm. June 19th through 20th, 1944, the Battle of the Philippine Sea. Aoi was at Yokosuka when the first fragmentary reports arrived. They were confused, contradictory, almost incoherent in places. But one thing was absolutely clear. Something catastrophic had occurred. Over the next several days, as survivors straggled back to Japanese bases and reports were compiled, the full picture emerged. It was worse than anyone had imagined. Japanese carrier forces had launched approximately 430 aircraft against the American fleet in 4 major waves. American combat air patrols, primarily consisting of Hellcats, had intercepted them with devastating effectiveness. The result? Approximately 300 to 30 Japanese aircraft destroyed. American losses, 29 aircraft. American pilots immediately dubbed it the Great Marianas Turkey Shoot. The name captured everything about how one-sided the engagement had been. It was not a battle, it was a massacre. The kill ratio, approximately 19-1. When survivor reports were fully compiled and analyzed, the same story emerged repeatedly. Japanese pilots described encountering what seemed like clouds of Hellcats, dozens of them, perfectly coordinated, directed by shipboard radar to optimal interception points. The Japanese formations were shredded before they could even approach the American fleet. One pilot, Lieutenant Junior Grade Zenji Abe, was debriefed by Aoi personally when he returned to Japan for reassignment. His account was harrowing in its matter-of-fact description of overwhelming defeat. They were everywhere. We never had a numerical advantage for even a single moment. They dove on us, fired, broke away cleanly. If we tried to chase, more Hellcats dove from above us. If we tried to continue toward the fleet, they pursued and shot us down from behind. We could not turn to engage them because there were always more of them positioned to attack while we were turning. I saw our entire Formation 18 aircraft reduced to 3 survivors in less than 10 minutes. "How many Hellcats did you face?" Aoi asked. "I cannot say with certainty," Abe replied, his voice hollow. 10, 20, 30? They all appear identical. Dark blue, very fast, very aggressive. I fired at one, saw hits along the fuselage, and it simply rolled away, trailing smoke, and continued flying. I have never seen anything like it. I have never felt so helpless in an aircraft. He paused, and his voice dropped to barely above a whisper. "We are not just being outfought, Commander. We are being outmatched so completely that fighting spirit does not matter anymore. I watched our best pilots' men with dozens of victories, men who flew at Pearl Harbor shot down like students on their first training flight. The Americans have better aircraft, better tactics, better coordination, and there are so many of them, so many." Aviation's collective consciousness. The myth of the Zero's invincibility was completely destroyed. The kill ratio had become strategically unsustainable. At current loss rates, Japan would run out of trained pilots within a matter of months, regardless of how many replacement aircraft could be produced. That evening, Aoi drafted a formal proposal and submitted it through official channels. The performance disparity between American and Japanese fighter aircraft has reached critical levels that threaten the continued viability of Japanese naval air operations. Request authorization to conduct comprehensive testing of captured enemy aircraft, specifically the F6F Hellcat, to determine exact performance advantages and inform necessary tactical and developmental responses. Given current loss rates, time is of extreme importance. To his surprise, the proposal was approved within 1 week, not because his superiors had suddenly come to value objective technical analysis over operational tradition, but because they were desperate. The Imperial Navy was losing the air war at a catastrophic rate, and even the most tradition-bound officers could no longer ignore it. In July of 1944, Aoi received official orders. A damaged but potentially repairable F6F3 Hellcat had been recovered from a crash site near Saipan before American forces could destroy it. The aircraft was being transported to Yokosuka Naval Air Technical Arsenal. He was to assemble a qualified team, repair the aircraft to flight-worthy status, and conduct comprehensive performance testing and tactical evaluation. Finally, after months of accumulating intelligence reports and pilot testimonies, he would have the opportunity to understand the enemy by flying their machine and thinking like their engineers. The Hellcat arrived at Yokosuka on October 2nd, 1944. The flatbed truck carrying the Hellcat rolled through the gates of Yokosuka Naval Air Technical Arsenal just after dawn. Tarps covered the aircraft, but its size was evident even beneath the covering. When the tarps were removed in the maintenance hangar, Aoi's first reaction was visceral. This was not an aircraft in the sense he understood the term. This was a weapon system. The Zero was beautiful. Graceful lines, elegant proportions, every curve optimized for airflow and minimum drag. It looked like what it was, a pure fighter, designed by men who loved aviation for its aesthetic as much as its function. The Hellcat was brutal, thick wings that seemed almost crude in their proportions, a massive radial engine that dominated the front of the aircraft, a slab-sided fuselage with none of the Zero's flowing curves, gun ports that looked large enough to swallow a man's fist. It looked like it had been designed by men who wanted to kill efficiently and return home alive. The aircraft was in poor condition. The pilot, identified from papers found in the cockpit as Lieutenant Junior Grade Robert Chen, had bailed out after sustaining combat damage over Saipan. The Hellcat had crash-landed in shallow water near the beach. Japanese infantry had recovered it before American forces could destroy the wreckage. There was substantial damage: a shattered canopy, crumpled landing gear, torn skin along the left wing root, and battle damage throughout bullet holes, many of them. But the engine appeared structurally intact, and the airframe's main spars were sound. It could be repaired. Aoi assembled his team carefully. 6 engineers from Mitsubishi and Nakajima, the companies that built Japan's fighters. 3 experienced mechanics who specialized in foreign equipment. 2 other test pilots, Lieutenant Shiga, who had flown at Pearl Harbor and Midway, and Lieutenant Minoru Suzuki, one of Yokosuka's most skilled evaluators. An interpreter who specialized in English technical documentation to translate the aircraft's manuals and placards. Their assignment had 2 phases. First, repair all the Hellcat to flying status. Second, understand it completely. The next 3 weeks became an intensive technical education that would fundamentally alter how these Japanese engineers understood air combat. They began with what American pilots called the Big Stoop, the Pratt and Whitney R-2800 double wasp engine. It was enormous. 18 cylinders arranged in 2 rows of 9 each, total displacement of 2,800 cubic inches, compared to the Zero's Sakai engine at 1,700 cubic inches. Dry weight, 2,360 pounds more than the entire empty weight of some Japanese fighter aircraft. Engineer Takeo Doi performed the calculations, his hands shaking slightly as he wrote the numbers. The R-2800 weighs more than twice what our Sakai engine weighs, but produces nearly twice the power. The power-to-weight ratio is actually similar, but the absolute power... He trailed off, staring at the SAML specifications they had compiled from technical documentation found with the aircraft. 2,000 horsepower at 2,700 revolutions per minute. "We have nothing remotely comparable," Lieutenant Suzuki said quietly. "The Homar engine for the Raiden produces 1,820 horsepower at maximum output, and it is chronically unreliable. This is a standard production engine in frontline service on thousands of aircraft, and it is more powerful than our most advanced experimental designs." They examined the engine's construction with something approaching awe: sophisticated 2-stage supercharging for high-altitude performance, a massively robust crankshaft, high-quality steel alloys in every critical component. The Americans had mastered metalworking and manufacturing at a level Japanese industry was struggling to match. Next, they turned their attention to the airframe itself. The wings were extraordinarily thick compared to any Japanese fighter, nearly twice the thickness of a Zero's wing at the root. But when they examined the internal structure, they understood why. Immensely strong main spars ran the length of each wing. Redundant structural members provided backup load paths if primary structures were damaged. And integrated throughout the structure was something these Japanese engineers had never seen in a fighter aircraft: armor plating built into the airframe itself. Behind the pilot's seat, a plate of face-hardened steel, 3/8 of an inch thick. In front of the pilot, armored glass windscreen, 2 inches thick, capable of stopping rifle-caliber rounds. Under the pilot's seat, additional armor protecting from below. Around the oil cooler, more armor. Protecting the engine accessories, armor. Surrounding the fuel tanks, armor. They carefully removed and weighed each piece of protective plating. The armor alone accounted for approximately 240 pounds, roughly 5% of the Hellcat's total empty weight. "The Zero has no armor whatsoever," Doi observed, his voice quiet with the weight of realization. "We save every possible gram for performance advantages. But look," he gestured at the removed armor plates arranged on the hangar floor. "They are carrying the equivalent of an additional pilot in protective weight alone. and their aircraft still outperforms ours in nearly every category. Because of the engine, Aoi said. That is the fundamental difference. With twice the power, they can afford armor. They can afford heavier structure. They can afford 6 guns instead of 2. They can afford everything we had to sacrifice. The fuel tanks provided another revelation. Self-sealing fuel tanks, what American technical documentation called protected tanks. The construction was ingenious. When a bullet pierced the tank wall, it also pierced a rubber lining inside. Aviation fuel caused this rubber to swell immediately, sealing the hole within seconds. The tanks could sustain multiple hits without leaking significantly or catching fire. Zero fuel tanks were thin aluminum, completely unprotected. A single bullet could rupture them, spilling 100-octane gasoline throughout the airframe. A single tracer round could transform the entire aircraft into a fireball. The engineers had all heard the stories every Japanese pilot had about Zeros exploding from single hits, pilots burning alive before they could bail out. They had attributed it to bad luck, to skilled enemy gunnery, to 1,000 things, except the obvious truth. The Zero was designed to burn. Then there were the guns. 6 Browning M2 50-caliber heavy machine guns, 3 mounted in each wing. They carefully removed one and examined its construction. It was beautifully manufactured precision engineering throughout. Chrome-lined barrel, robust feed mechanism designed for reliability under high-G combat maneuvers. Rate of fire, 750 to 850 rounds per minute, per gun. Total firepower, approximately 900 rounds per minute across all 6 guns combined. Each 50-caliber round carried significantly more kinetic energy than the Zero's 7.7mm rounds, and nearly as much as the 20mm cannon rounds, while firing much faster and with much greater ammunition capacity. They test-fired one gun carefully, using ammunition recovered from the aircraft into a steel plate set up at the edge of the airfield. The 50-caliber rounds punched completely through steel that would stop the Zero's 7.7mm rounds without penetrating. They can destroy us at ranges where our lighter guns cannot hurt them, Lieutenant Shiga observed, examining the punctured steel plate. And when they fire, they put so many rounds into the air that precise aiming becomes almost unnecessary. They simply point in our general direction and hold the trigger, and we disintegrate. The engineers were beginning to understand the fundamental philosophical difference between the two designs. The Zero philosophy: build the lightest, most maneuverable fighter physically possible, rely on superior pilot skill to avoid being hit, achieve victory through dogfighting superiority and pilot quality. The Hellcat philosophy: build a fighter that can absorb punishment, deliver overwhelming firepower, and use speed and power to control the terms of every engagement. Achieve victory through technological superiority, combined with tactical doctrine. These were incompatible worldviews, embodied in aluminum and steel. And in 1944, the American worldview was winning decisively. October 25, 1944. After 3 weeks of intensive repair work, the Hellcat was ready to fly. They had fabricated new landing gear components from salvaged parts and raw materials, patched and reskinned the damaged wing section, repaired the hydraulic systems, replaced the shattered canopy from another crashed aircraft. Throughout the repairs, they had been struck repeatedly by the robust nature of American engineering. Components were designed with generous safety margins. Systems had backups. Everything was built to survive damage and keep functioning. The engine ran smoothly, surprisingly smoothly for a motor that had been in a crash landing and soaked with salt water. American manufacturing tolerances were extraordinarily tight. Even after such treatment, the R-2800 fired up and purred like it had just left the factory. They had painted over the American markings with Japanese Hinomaru roundels, but the Hellcat still looked unmistakably foreign sitting on the Yokosuka flight line. Several young pilots gathered at a distance to watch, curious about this legendary enemy fighter that had been killing their comrades across the Pacific. Aoi would make the first flight. He was the most experienced test pilot on the team, and this was potentially dangerous. They were flying a repaired enemy aircraft with possible hidden damage from combat and crash landing. If something went catastrophically wrong, better to lose a 36-year-old test pilot than a 19-year-old combat pilot who might still survive the war. He walked around the aircraft one final time, conducting his pre-flight inspection. Up close, the Hellcat looked even more massive. The propeller blades were huge, 13 feet in diameter. The landing gear was thick and sturdy, built to withstand the violent impacts of carrier landings. Everything about it suggested solidity and strength rather than elegance and finesse. He climbed into the cockpit. It was spacious, much roomier than the cramped Zero cockpit he was accustomed to. The seat was adjustable in multiple directions. He had to stuff towels behind his back to reach the rudder pedals comfortably. The cockpit was sized for larger American pilots. Everything was labelled in English, but he had studied these controls for days. He understood each switch, each lever, each gauge. More than that, he understood what the gauges would tell him, because they had calculated the aircraft's performance from its design specifications. But calculation was different from experience. Numbers on paper could not capture what it actually felt like to fly this machine. The engine start procedure was more complex than Japanese fighters. Mixture control had to be set properly, propeller pitch adjusted, oil cooler shutters opened, cowl flaps positioned correctly. The Americans had automated almost nothing. The pilot controlled everything manually. But once the engine was running, it was smooth and powerful, vibrating the entire aircraft with barely contained force. He taxied toward the runway. Visibility over the nose was poor. The massive engine cowling blocked forward view during ground operations. He had to weave back and forth in S-turns to see where he was going. But the controls were responsive. The aircraft felt solid and stable. At the runway threshold, he took a deep breath. This was the machine that had been killing his fellow pilots for over a year. The aircraft that represented everything Japanese naval aviation was fighting against. Now he was going to fly it, understand it from the inside, and hopefully learn how to counter it. Though somewhere deep in his mind, he suspected he was about to learn something far more disturbing, that it could not be countered with current Japanese equipment. He advanced the throttle to full power. The acceleration was unlike anything Takahide Aioi had ever experienced in an aircraft. The Hellcat leaped forward as if catapulted. 2,000 horsepower drove the massive propeller, and that power translated into tremendous thrust. The runway markers blurred past. The tail came up almost immediately. The propeller thrust was enormous. He was airborne in perhaps 800 feet, less than half the distance a Zero needed for takeoff. The climb rate was extraordinary. 1,000 feet in seconds, 2,000 feet almost immediately. The vertical speed indicator showed 3,500 feet per minute, better than a Zero, despite carrying twice the weight. He leveled off at 5,000 feet to gain a feel for the aircraft's handling characteristics. The controls were heavy compared to a Zero, much heavier. You did not fly the Hellcat with fingertips and gentle suggestions. You muscled it around with firm, deliberate control inputs. But the response was immediate and predictable. There was a sense of mass and solidity to every movement, like controlling a much larger aircraft than it actually was. He tried a level speed run at full power. The airspeed indicator climbed steadily, 250 knots, 280 knots, 300 knots, 320 knots. At maximum continuous power, he was indicating 330 knots, approximately 380 miles per hour, 30 miles per hour faster than a Zero at this altitude, and the advantage would increase at higher altitudes where the Hellcat's two-stage supercharger provided even greater power. But speed was only one dimension of fighter performance. He pulled the Hellcat into a hard turn, banking steeply and pulling back on the stick. The G-forces built rapidly, the aircraft was heavy, and the turn rate was moderate by Japanese standards. A Zero would be inside this turning circle easily, able to pull around faster and get onto the Hellcat's tail. But then he remembered the intelligence reports and pilot testimonies. American pilots never turned with Zeros. They refused to fight that battle. They had learned that lesson after analyzing captured Zeros and developing new tactical doctrine. He rolled out of the turn and tried what American pilots called boom and zoom tactics. He climbed to 8,000 feet, then pushed the nose down into a dive. The airspeed built rapidly. 350 knots, 380 knots, 400 knots. The controls grew heavier as speed increased, but the aircraft remained rock steady. No flutter, no buffeting, no warning signs of structural stress. The Hellcat was built to dive at these speeds. At 3,000 feet, he pulled out hard. The G-forces slammed him down into the seat with tremendous force. His vision started to grey at the edges, the acceleration was intense, but the Hellcat handled it without any complaint. No structural creaking. No warning sounds. The aircraft was built to withstand these forces. A Zero would have shed parts in that pullout. The lightweight structure could not handle those G-forces at that speed. He had seen it happen during testing Zeros, experiencing structural failure during high-speed pullouts from dives. He climbed back to altitude and tried the maneuver again, this time imagining he was a Hellcat pilot bouncing a Zero from above. Dive from superior altitude, accelerate to 400 knots, make a high-speed gun pass on the target, then use the tremendous speed and power to zoom climb back to altitude before the enemy can react. It worked perfectly. The Hellcat was an ideal platform for this tactic, fast enough in the dive to catch any Japanese fighter, powerful enough to climb back to safety before retaliation, robust enough to handle the extreme G-forces and speeds involved in the maneuver. He had been flying for only 20 minutes, but he had already learned more than months of intelligence reports and pilot testimonies could convey. This was not just a better aircraft than the Zero in some abstract statistical sense. It was better in every way that mattered for the air war being fought in 1944. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Then he remembered the guns. He descended to 3,000 feet over the bay. They had designated this as a safe area for weapons systems testing. He activated the gun camera, but would not actually fire. They had only limited ammunition, and it needed to be preserved for technical evaluation. But he could simulate combat passes and evaluate the gun sight system. He lined up on an imaginary target and pressed the trigger button without firing. The gun sight was excellent, a simple but effective reflector sight that projected a bright aiming circle onto a clear glass panel in front of the pilot. With 6 guns converging at 300 yards, a pilot did not need to be particularly accurate. Just get the target somewhere within that circle and fire. The sheer volume of fire would do the rest. He tried tracking a simulated evasive target through a turn. The Hellcat's speed made it easy to stay in firing position, even as an imaginary Zero tried to turn away. An American pilot would simply hold down the trigger, pouring rounds into the target continuously until it disintegrated. 6 50 caliber guns firing 900 rounds per minute combined would literally see an aircraft apart. After 45 minutes of flight testing, he returned to Yokosuka. The landing was straightforward, visibility over the nose was poor, but the aircraft was stable and forgiving. The landing gear absorbed the impact solidly. Everything about the aircraft felt robust and reliable. When he climbed out of the cockpit, his flight suit was completely soaked with sweat. But it was not from fear or physical exertion. It was from understanding. From the terrible clarity of finally knowing exactly what Japanese pilots were facing and why they were dying in such numbers. In the conference room 1 hour later, Aoi faced his assembled team and 2 senior officers from Navy headquarters, who had travelled specifically to hear his assessment. "Gentlemen," he began, choosing his words with extreme care, "I need to be completely frank. What I am about to tell you is not encouraging." He presented his findings systematically, using the language of engineering and objective measurement. Performance advantages. The Hellcat is faster than the Zero at all altitudes, 30 to 50 kilometers per hour faster, depending on altitude. Despite being twice the weight, it has a better climb rate due to the power advantage. Far superior dive performance, 50 km per hour faster in dives and much more stable structurally. Better high-altitude performance due to the two-stage supercharger. Greater range and endurance despite higher fuel consumption due to much larger fuel capacity. Firepower advantages. 6 heavy machine guns compared to the Zero's 2 cannons and 2 light machine guns. 2 to 3 times the total firepower delivery. Much higher ammunition capacity allowing sustained fire. Can destroy a Zero with a 1 to 2 second burst. Effective at longer ranges than our lighter weapons. Survivability advantages. Comprehensive pilot armor. Protection, the Zero has none. Self-sealing fuel tanks, the Zero has none. Robust structure capable of absorbing 10 to 15 times more battle damage. Can survive hits that would destroy a Zero instantly. Better crashworthiness and ditching characteristics. Tactical advantages. Boom and zoom tactics are perfectly suited to the aircraft's strengths. Can engage and disengage at will due to speed advantage. Controls the high-speed combat envelope completely. The Zero cannot force engagement on unfavorable terms. The only advantage the Zero retains, Aoi said quietly, is turning radius at low to moderate speeds, and that advantage is operationally meaningless, because Hellcat pilots simply refuse to engage in turning combat. They have learned not to fight our fight. One of the officers from headquarters, Captain Yoshida, interrupted. Surely our most skilled pilots can exploit the Zero's superior maneuverability to achieve victories. No, sir, Aoi said firmly but respectfully. With respect, I have now flown both aircraft. If I am in a Hellcat and you are in a Zero, you cannot make me turn with you. I can dive away at any time and you cannot catch me. Your maximum dive speed is limited by structural constraints. Mine is not. I can climb away using superior power, and you cannot follow. I can engage at my choice of time and place, and you can only react. The initiative belongs entirely to the Hellcat pilot. He paused, letting that sink in before delivering his devastating conclusion. The Hellcat is not merely better than the Zero. It is superior in every dimension that matters in modern air combat as of 1944. It is faster, more powerful, more durable, better armed, and designed around tactical doctrine that we have no effective counter for. The kill ratio we have been experiencing, approximately 19-1 in the Hellcat's favour, is not surprising to me after flying this aircraft. It is the logical, predictable result of the performance gap. The room was silent. Several officers shifted uncomfortably. Captain Yoshida's expression was grim. Can our pilots adapt their tactics? Another officer asked. Better training? Revised doctrine? Our pilots are already among the finest in the world, Aoi responded carefully. They are brave, skilled, and determined. But they are fighting with inadequate equipment against an enemy doctrine specifically designed to negate our advantages while exploiting our weaknesses. It is like, he searched for the right analogy, like bringing a sword to a gunfight and being told to win through superior swordsmanship. Lieutenant Shiga, who had flown at Pearl Harbor and Midway and survived more combat than almost any pilot in the room, spoke up to support Aoi's assessment. I have fought against the Hellcats over Rabaul. Everything Commander Aoi describes matches our combat experience exactly. Every single advantage he documented is real. We see it every time we engage them. The Americans have built a fighter specifically to kill Zeros, and they have succeeded completely. What do you recommend, Commander Aoi? Captain Yoshida asked, his voice heavy. Aoi chose his words with extreme care, knowing he was walking a political tightrope. We need new fighter aircraft urgently. Not improved Zeros, fundamentally different fighters with 1,800 to 2,000 horsepower engines, armor protection, heavier armament, and robust structure capable of absorbing battle damage. The J-2M Raiden and N-1KJ Shiden are steps in the correct direction, but they need accelerated development and immediate deployment in large numbers. And in the meantime, while we wait for new aircraft? In the meantime, sir, we must be realistic about what the Zero can and cannot accomplish. It remains an excellent fighter for certain missions: interception of unescorted bombers, escort duties at normal altitudes, combat against older Allied fighters. But against Hellcats employing proper American tactics, we should expect heavy losses. We cannot change that reality without changing our equipment. What Aoi did not say, could not say in this formal setting, was what he was really thinking. We have already lost the air war. The only question now is how long it continues and how many more young pilots die before we acknowledge defeat. Over the following 2 weeks, they conducted comprehensive additional testing that confirmed and expanded upon Aoi's initial findings. Lieutenant Shiga flew the Hellcat and submitted his own evaluation report. His conclusions were stark. This aircraft has made me understand why we are losing the air war. If I were offered a choice between flying a Zero or a Hellcat into combat, I would choose the Hellcat without any hesitation whatsoever. Our pilots are not dying due to lack of skill or courage. They are dying because they have been sent to fight in obsolete equipment against a technologically superior enemy. Lieutenant Suzuki conducted comparative mock dogfighting tests, Hellcat versus Zero, in simulated combat. He flew the Hellcat while an experienced Zero pilot, Lieutenant Kenji Okabe, attempted to shoot him down following standard Japanese fighter tactics. The result was unambiguous. The Zero could not get onto the Hellcat's tail unless the Hellcat pilot made serious mistakes. The Hellcat could disengage from combat at will. When the Hellcat pilot employed proper boom and zoom tactics, the Zero was essentially helpless, unable to catch the diving Hellcat, unable to climb fast enough to re-engage, unable to force the Hellcat into a turning fight. They reversed roles for a second test, Suzuki in the Zero, Okabe in the Hellcat. This time, the Hellcat achieved a kill on the Zero during the very first attack pass. The Zero never had an opportunity to use its turning advantage. The engineers conducted structural testing, carefully taking the Hellcat to its G-load limits. They found it could sustain forces that would cause catastrophic structural failure in a Zero. They examined the crashed landing gear and discovered it was engineered to handle repeated carrier landings, essentially 15-foot drops at high sink rates, over and over, without failing. Zero landing gear was far more fragile, designed only for smooth runway operations. They analyzed every system: the hydraulics, the electrical systems, the radio equipment. Every system demonstrated the same philosophy: robust, redundant, designed for combat damage survival. If one component failed, backups existed. If a system was damaged, it degraded gracefully rather than failing catastrophically. They completely disassembled the engine. The manufacturing quality was extraordinary: precision tolerances throughout, high-quality alloy steels, thoughtful engineering with maintainability in mind. It was designed to operate for hundreds of hours between major overhauls. Japanese engines, by contrast, were becoming increasingly unreliable, requiring frequent maintenance with increasingly scarce spare parts. Commander Okumiya compiled a strategic intelligence assessment comparing American and Japanese aircraft production capacity. The United States is currently producing approximately 5,000 Hellcats per month. At current rates, they will produce more Hellcats during calendar year 1944 than Japan has produced total Zeros since 1940. Furthermore, the Hellcat is already being supplemented by even more capable fighters: the F-4U Corsair, which is faster and more powerful, and the P-38 Lightning, and soon the P-51 Mustang. We are not competing with one American fighter design. We are competing with an entire industrial system, producing multiple superior designs simultaneously. He paused before adding the most damning assessment: "Gentlemen, we are not simply being outfought. We are being outproduced at a ratio of approximately 6-to-1 in terms of class of face, total combat aircraft, and the aircraft being produced are qualitatively superior to our own. There is no realistic scenario in which Japan can win a prolonged air war under these material conditions." November 15th, 1944. Aoi submitted his final comprehensive report to Imperial Navy Headquarters. The document was 127 pages long, containing detailed technical specifications of the F6F3 Hellcat, comparative performance analysis versus the A6M Zero, tactical recommendations for Japanese pilots, recommendations for future Japanese aircraft development, and a strategic assessment of the air war. The report's conclusions pulled no punches. The F6F Hellcat represents a fundamental paradigm shift in fighter aircraft design philosophy, where Japanese fighters prioritize maneuverability and pilot skill above all other considerations. The Hellcat prioritizes firepower, survivability, and speed. In the context of air combat as it exists in 1944, the American design philosophy is demonstrably superior. The current kill ratio of approximately 19:1 in favor of the Hellcat over the Zero is explained by the following factors. First, a superior speed and climb rate, allowing American pilots to control engagement parameters. Second, the overwhelming firepower advantage allows rapid destruction of enemy aircraft. Third, survivability features allow damaged aircraft to return home rather than being lost. Fourth, tactical doctrine that systematically exploits these technological advantages. Fifth, numerical superiority due to vastly greater production capacity. Recommendations. First, immediately prioritize development and production of fighters with 2,000 horsepower engines. Second, retrofit existing fighters with pilot armor and protected fuel tanks where structurally possible. Third, develop new tactical doctrine that acknowledges American advantages and seeks methods to minimize their impact. Fourth, increase pilot survival training and equipment. Fifth, adjust strategic planning to reflect realistic assessments of Japanese air power capabilities versus American capabilities. Without significant changes in equipment and doctrine, Japan cannot contest air superiority against American forces equipped with F6F Hellcats and similar advanced aircraft. Aoi personally hand-delivered the report to Captain Yoshida at Navy headquarters in Tokyo. 3 days later, he was summoned to a meeting. Captain Yoshida's office overlooked Tokyo Bay. Through the window, Aoi could see American B-29 bombers had hit the city the previous night. Smoke still rose from fires in the industrial district. "Commander Aoi, your report is technically excellent," Captain Yoshida began. "The analysis is thorough and the conclusions are well supported by the evidence you have gathered." There was a long, uncomfortable pause. "However, we cannot distribute this report widely, beyond a very limited circle." Aoi felt his heart sink, though he had half expected this. "Sir? Your conclusions about the kill ratios, about the aircraft's overwhelming superiority, these findings are potentially damaging to morale. If this report circulates among combat pilots or becomes widely known, it could undermine fighting spirit at a critical moment in the war." "Sir, with the greatest respect, the pilots already know these things," Aoi said, struggling to keep his voice level. "They are the ones being shot down. They are the ones facing Hellcats every day. They know, nevertheless." Captain Yoshida's voice was firm, cutting off the objection. "The report will be classified, secret, very limited distribution only. The technical specifications may be shared with aircraft designers at Mitsubishi and Nakajima, as they need this information for development work. But the tactical and strategic assessments will be restricted to senior staff officers only." "But, sir, if we do not acknowledge the reality of our situation, Commander Aoi," the captain's tone softened slightly, "I want you to understand something. I agree with your analysis. I have read your report carefully, and I believe your conclusions are correct. But there are considerations beyond pure technical assessment. The Army and Navy are competing for scarce resources. If we acknowledge openly that we are being so thoroughly defeated in the air, it could impact procurement decisions, strategic planning, everything. It could affect morale across all services. So we continue fighting with equipment we know is inadequate. We continue fighting," Captain Yoshida said, meeting Aoi's eyes directly, "while we develop better equipment as quickly as our industrial capacity allows." Your recommendations regarding new fighters have been noted and will inform future development, but we cannot afford to spread defeatism through the ranks. The war must continue. Aoi wanted to argue that objective technical analysis was quintupia, not defeatism. It was the foundation of effective strategy. He wanted to say that sending pilots to die in equipment, is inadequate, while suppressing the analysis that proves it is not honor but waste. But he could see it was pointless. The decision had been made at levels far above this office. The report was stamped with red ink, secret, restricted distribution. It was filed away in a secure vault at Navy headquarters. Only a handful of senior officers ever read it. The combat pilots who were dying daily over the Philippines, over Iwo Jima, over Okinawa pilots who desperately needed to understand what they were facing never saw it. The tactical recommendations that might have saved lives were never widely implemented. The strategic warnings were noted and then ignored, because acknowledging the full truth that Japan was losing the air war decisively due to fundamental technological inferiority that could not be quickly remedied was incompatible with the political and cultural requirements of continuing the war. December 1944 through August 1945, the war's final 9 months. Aoi continued his work at Yokosuka, but the nature of that work changed dramatically. There were no more captured enemy aircraft to test. The Americans were advancing everywhere now, and Japanese forces had no opportunity to recover intact aircraft from crash sites before being overrun. Instead, Aoi's team worked on desperate improvisations, trying to upgrade existing aircraft with minimal materials, evaluating emergency designs built from whatever resources remained, testing experimental weapons that seemed increasingly fantastical, rocket-powered interceptors, ramming aircraft, anything that might give Japanese pilots some advantage. The new Japanese fighters began trickling into service: the J-2M Raiden, the N-1KJ Shiden, the Ki-84 Hayate. They were genuinely good aircraft when they worked better than the Zero, closer to parity with American fighters. But they came too late, in far too small numbers, plagued with reliability problems that Japan's degraded industrial capacity could not solve. And they still faced the fundamental problem: insufficient engine power. The best Japanese fighters had engines producing 1,850 horsepower. By 1945, American fighters had engines producing 2,400 to 2,800 horsepower. The gap was widening, not closing. The Americans introduced new fighters as well: the F-4U Corsair, which was even faster than the Hellcat; the P-51 Mustang, which could escort B-29 bombers all the way from the Marianas to Tokyo and back; the P-47 Thunderbolt, which was nearly invulnerable to ground fire and could destroy almost anything it hit. The kill ratios grew worse. By early 1945, in some engagements, they exceeded 30-1 in favor of American aircraft. Aoi watched the young pilots arrive at Yokosuka for abbreviated training. They were teenagers, now some as young as 17 years old. The experienced pilots were dead, shot down over the Philippines, over Formosa, over Iwo Jima, over Okinawa. These boys received perhaps 100 hours of flight training before being sent to combat units, compared to the 600 or more hours that pilots received in 1941. He knew that most of them would be dead within weeks of reaching their units. In April of 1945, Aoi was assigned to provide technical evaluation for a new tactic, Tokko, or special attack, the kamikaze strategy. If Japanese pilots could not win air-to-air combat anymore, they would achieve a 1-to-1 exchange rate by deliberately ramming their aircraft into enemy ships. It was a tactical admission of absolute defeat, dressed up in the language of ultimate sacrifice and warrior spirit. Aoi provided technical recommendations for aircraft modifications, removing unnecessary weight, adding armor around the bomb, adjusting fuel loads for one-way missions. But his heart was not in the work. This was not aviation anymore. This was organized suicide. The kamikaze attacks achieved some successes. They sank ships, damaged carriers, and killed American sailors. But at a horrific cost, thousands of pilots died, most of them without even reaching their targets. American fighter patrols and anti-aircraft defenses shot down the majority of kamikaze aircraft long before they could attack. And still the Americans kept coming. More carriers, more aircraft, more pilots. An endless industrial tide that Japan had no hope of matching. By June of 1945, American fighters were flying over Tokyo with virtual impunity, shooting down the occasional Japanese fighter that challenged them, escorting massive formations of B-29 bombers that were systematically burning Japanese cities to ashes. Then came the atomic bombs. Hiroshima on August 6th, Nagasaki on August 9th. On August 15th, 1945, Emperor Hirohito's voice crackled over the radio, announcing Japan's surrender. The war was over. Aoi listened to the broadcast in the officers' mess at Yokosuka. Around him, some men wept, others sat in stunned silence. A few looked almost relieved. He felt empty, hollowed out. He had known for nearly a year that defeat was inevitable. He had documented it, quantified it, and reported it, and then watched as thousands more young pilots died while that knowledge remained classified and unused. September 1945. American occupation forces arrived at Yokosuka Naval Air Technical Arsenal. Among them was a team of United States Navy technical intelligence officers, led by Commander Jackson, an aeronautical engineer who had worked on fighter development in the United States before the war. They wanted to inspect the facility, examine Japanese aircraft, and understand Japanese aviation technology. Aoi was assigned as their guide and translator. His English was functional, learned from technical manuals and academic papers. It felt strange, walking through the hangars with former enemies. But Commander Jackson was professional, even friendly. He was genuinely interested in Japanese aircraft design, asked intelligent questions about the Zero and other fighters. "You built some genuinely impressive aircraft," Jackson said, examining a Zero in one of the hangars. The Zero was unquestionably the best carrier fighter in the world in 1941. Our pilots feared it. But not in 1944, Aoi responded quietly. "No," Jackson agreed, meeting his eyes. "Not in 1944. They walked to another hangar, where the captured Hellcat still sat, exactly where Aoi had left it after his last test flight 10 months earlier. Seeing it, Jackson smiled slightly. "You test flew this one?" he asked. "Yes," Aoi confirmed. "In October of last year. What did you think?" "Honest. Assessment, engineer to engineer." Aoi considered how to answer, then decided on complete honesty. "I understood immediately why we were losing the air war." Jackson nodded slowly, his expression respectful. The Hellcat was designed specifically to fight the Zero. We studied captured Zeros. One crashed nearly intact in the Aleutians in 1942. We analyzed everything about it. Then Grumman built a fighter specifically to counter every advantage the Zero had. "I know," Aoi said. "I wrote a comprehensive report about it." "May I see that report?" Aoi retrieved one of the 5 copies from the facility's archives, still stamped secret in red ink. Commander Jackson read it carefully, taking nearly an hour. When he finally looked up, there was something like professional respect in his expression. "This is excellent technical analysis, Commander. Your conclusions match our own testing almost exactly. You clearly understood the Hellcat's advantages very thoroughly. The kill ratio prediction 19-1 is remarkably accurate." Yes, it was. Jackson paused, seeming to choose his words carefully. "Commander, may I ask, when did you complete this report?" "November of 1944. And was it distributed? Used to modify tactics or inform strategy?" "No," Aoi said simply. It was classified and filed away. Too damaging to morale, I was told. Jackson was silent for a long moment. Then, I am sorry. That must have been extraordinarily frustrating. It was difficult, Aoi admitted, surprised by how much it meant that someone understood. Watching pilots die while knowing exactly what they were facing. Knowing we had analyzed it and understood it, but could not or would not change anything in response. They walked outside into the September sunshine. In the distance, American transport aircraft were landing at the airfield C-47s, bringing occupation supplies, bringing the machinery of the new order. "What will you do now?" Jackson asked. "I do not know," Aoi said. "I am an aeronautical engineer. Perhaps I can help rebuild Japan's aviation industry. If we are permitted to have one." "You will be," Jackson assured him. "Not military aircraft for some time, but civil aviation, certainly. Japan will need commercial aircraft, and you have the expertise." As they stood there, watching American aircraft come and go, Aoi thought about everything that had happened. About the war, about the young pilots who died, about the Hellcat and the Zero, and the technological race that Japan had lost before it truly began. "May I tell you something?" Aoi said. "A conclusion I reached, flying your Hellcat last year. Please. I realized that this war was decided as much by engineering as by fighting. You built better aircraft because you had better engines, better materials, better manufacturing capacity. We built elegant aircraft, beautiful aircraft, but they were not enough. Your philosophy build something robust that can absorb damage and continue fighting that was the correct philosophy for industrial warfare on this scale." He paused, gathering his thoughts. "We built aircraft for samurai. You built aircraft for soldiers. In a long war of production and attrition, soldiers equipped with superior tools will defeat samurai equipped only with spirit, no matter how determined that spirit may be." Jackson considered this carefully. There is truth in that assessment, though I would say your pilots were soldiers too, extraordinarily brave soldiers fighting with inadequate equipment. That was not their failure. That was a failure of strategy and industrial capacity. "Yes," Aoi agreed quietly. "That is exactly correct." In the years following the war, as Japanese aviation history was compiled, analyzed, and documented, the full irony of Aoi's story became clear to historians. The analysis was correct. His report accurately predicted the outcome of the air war. The 19-to-1 kill ratio, the technological gaps, the tactical recommendations, all proven accurate by subsequent events. The timing was wrong. The report came too late. By October of 1944, when the Hellcat testing occurred, Japan had already lost the war. The outcome was determined. Even if every recommendation had been implemented immediately with unlimited resources, there was no time to reverse the course of the conflict. The culture prevented action. Even when objective analysis was available and correct, the military culture prioritized maintenance of fighting spirit over acknowledgement of technological reality. Admitting inferiority was seen as defeatism, so the truth was suppressed to maintain morale. The enemy already knew. Everything Aoi discovered through testing the Hellcat, American engineers already knew because they had designed it. The gap was not in knowledge or understanding. The gap was in industrial capacity and technological capability to actually build such aircraft. The pilots knew too. Japanese pilots who fought Hellcats daily understood all the disadvantages Aoi documented in his report, but they had no voice in procurement or strategic decisions. They simply died, knowing they were outmatched. The most profound irony, Aoi's scientific objectivity and engineering expertise made him the perfect person to analyze the sources of Japan's defeat. But that same objectivity made his findings politically unusable within a military culture that valued subjective warrior qualities over objective technical analysis. Takahide Aoi survived the war. He worked in Japan's post-war aviation industry, eventually becoming a senior engineer at what would become Mitsubishi Heavy Industries, the same company that had built the Zero. He never flew military aircraft again. Instead, he helped design civilian aircraft, contributing to projects like the MU-2 and the YS-11, always focusing on passenger safety, structural robustness, and reliability. The lessons of the war informed everything he did. Build strong, build redundant, prioritize survivability. In the 1960s, he wrote a memoir about his wartime experiences. The section about testing the Hellcat was brief but devastating in its honesty. I flew the Hellcat for 45 minutes in October of 1944. In that short flight, I learned more about why we were losing the war than in 3 years of combat reports and intelligence analysis. The Americans had built a superior aircraft, not more beautiful, not more elegant, but better suited for the purpose of winning an industrial war of attrition. They had the engines, the materials, the production capacity, and the tactical doctrine to employ it all effectively. I wrote my report honestly, as an engineer must. I made recommendations, as a patriot should. But the war was already lost, and perhaps my report's only value now is historical. A document capturing the precise moment when Japanese engineering confronted the reality of American industrial power and understood that fighting spirit alone could not overcome such material superiority. The young pilots who died in their Zeros were not lacking in courage or skill. They were lacking in horsepower, armor, and firepower. That was not their fault. It was our fault, the engineers, the planners, the leaders who sent them to fight an unwinnable war with inadequate tools. I still carry that knowledge. The captured Hellcat was eventually scrapped after the war, cut up and melted down during the post-war reconstruction. But photographs survive. One shows Takahide Ioi standing beside it shortly after his test flight in October of 1944, still in his flight suit. He is not smiling. The story of Japanese engineers testing captured Hellcats reveals something fundamental about war, technology, and the limits of courage. The 19-to-1 kill ratio was not mysterious or inexplicable. It was the logical, predictable result of massive technological advantage, combined with tactical doctrine specifically designed to exploit that advantage. The Americans did not win because they were braver or more skilled than Japanese pilots. They won because they built superior machines, produced them in overwhelming numbers, and developed tactics that used those machines effectively. The Japanese did not lose because they lacked courage or fighting spirit. They lost because they entered an industrial war without adequate industrial capacity, and because their military culture sometimes valued subjective spiritual qualities over objective technical reality. When Takahide Ioi flew that Hellcat in October of 1944, he experienced a moment of profound clarity that came far too late to matter. He understood, viscerally and completely, what his nation was fighting against. He knew the war was lost. He knew thousands more young pilots would die before that loss was officially acknowledged, and he was powerless to change any of it. That is the tragedy at the heart of this story. Not that Japan lost the air war, that outcome was probably inevitable once American industrial production reached full capacity, but that the loss was foreseeable, quantifiable, and impossible to prevent, despite being thoroughly understood by those with the expertise to recognize it. The engineers knew. The test pilots knew. Many of the combat pilots knew. But knowledge without institutional power to act is merely informed despair. Wars are won by engineering as much as by courage, by logistics as much as by tactics, by industrial capacity as much as by warrior spirit. And sometimes the most valuable knowledge arrives too late. Sometimes the truth, no matter how clearly demonstrated through rigorous analysis, cannot overcome the momentum of national mythology and military culture that insists on continued sacrifice. Sometimes the men who understand best are the ones who can do the least. That was the burden carried by the Japanese engineers who tested captured Hellcats. They saw the future with perfect clarity, understood it completely through scientific analysis, and then watched it arrive exactly on schedule despite all their warnings. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The morning of July 26, 1944. Staff Sergeant Eugene Moffat pressed his eye against the commander's periscope of his M4 Sherman tank, scanning the tree line 800 meters ahead. The fog had lifted from the Norman hedgerows, and visibility was perfect, which in tank warfare meant exposure, vulnerability, death. His crew had named their Sherman Boilermaker after their home state of Indiana, white letters painted on the turret side like a promise to return. But promises meant nothing when you spotted the distinctive profile emerging from behind a stone farmhouse. The massive rectangular hull, the overhanging gun barrel, the interleaved road wheels that looked like armoured caterpillar tregs. A Tiger, Panzer VI. The tank every American crew had been warned about since Fort Knox, the mathematical nightmare that could kill you from 2,000 meters, while you struggled to scratch its paint from 400. Moffat's loader, Private Eddie Martinez from El Paso, was already lifting a 75mm round from the ready rack when Lieutenant Morrison's tank 40 meters to their left simply ceased to exist. The Tiger's 88mm gun had spoken once, and Morrison's Sherman became a funeral pyre for 5 men. 7 seconds later, the Tiger fired again. Sergeant Kelly's tank took the round through the frontal armour, and though it didn't fully penetrate, the kinetic shock broke Kelly's ankle and ignited the engine compartment. His crew bailed out through smoke and flames. 2 tanks gone, 10 men killed or wounded, 14 seconds. The mathematics were brutal and simple, exactly as the training manuals had promised. In a frontal engagement at range, the Tiger won, always. Except Eddie Martinez, ramming their 3rd shell into the breach, said something that would rewrite American tank doctrine for the rest of the war. Sarge, we're faster than him. This is the story of 37 seconds that proved superior. Firepower means nothing if you cannot reload fast enough to use it. It is about 5 Sherman crews who discovered that the German Tiger's greatest weapon, its devastating 88mm gun, contained a fatal flaw hidden in plain sight. And it is about the moment when American tank tactics, mocked by critics as the crude swarm strategy of throwing cheap machines at expensive ones, revealed themselves to be something far more calculated than anyone had understood. Sometimes, victory is not about hitting harder. Sometimes it is about hitting more often, faster, and with such relentless volume that your enemy never gets time to aim carefully again. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Eugene Moffat was 23 years old when he enlisted in November of 1942, 3 weeks after completing his mechanical engineering degree at Purdue University. He did not have to go. Engineers were draft exempt, their skills deemed too valuable for the production effort. But his older brother Tom had been killed at Kasserine Pass in February of 1943, commanding an M3 Stuart light tank in the 1st Armoured Division. The Western Union telegram arrived while Gene was calculating stress loads for a bridge design project. He remembered his mother's scream from downstairs, the sound cutting through 2 floors of their Indianapolis home. He remembered his father sitting motionless at the kitchen table, reading and rereading the same 3 sentences, as if repetition might change their meaning. He remembered deciding that night that if Americans were going to die in tanks, he wanted those tanks to be better, and the only way to make them better was to understand them from the inside. At Fort Knox in Kentucky, Gene learned that better was complicated. The M4 Sherman medium tank was not designed to fight German Tigers or Panthers in single combat. This was not a deficiency or oversight, it was deliberate doctrine based on industrial reality. Captain Theodore Morrison, who would later die in that first Tiger round on July 26th, taught their tank commander course with brutal honesty. Gene recorded Morrison's lecture in his training journal, dated March 18, 1944, and that journal now sits in the National Armour and Cavalry Museum at Fort Benning, Georgia. Morrison had said, "The Sherman was not designed to fight Tigers because there were no Tigers when we designed it. Hell, there were no Shermans when we designed it. We built a tank that we could produce in massive numbers, maintain in the field with our logistics tail, and ship across an ocean without specialized equipment. Could we have built a heavier tank with a bigger gun? Certainly. We built the M26 Pershing. Do you know how many made it to Europe before Germany surrendered? 20. 20 tanks. That is what happens when you optimize for individual superiority instead of systemic advantage. The numbers told their own story, and Gene copied them meticulously into his notes. The United States produced 49,234 Sherman tanks during the Second World War. Germany built 1,347 Tiger I tanks. That ratio, 36-1, represented a fundamental philosophical difference in how each nation approached armoured warfare. The Germans built Wunderwaffen, wonder weapons, machines of individual technical superiority. Each Tiger cost 655,000 Reichsmarks and required 300,000 man-hours to produce. Each Sherman cost $44,500 and required 10,000 man-hours. But that ratio meant nothing to the 5 men inside a Sherman when they spotted a Tiger. Eddie Martinez, Gene's loader, summed it up during a smoke break after training. So we are the 49,000, right? Great. But if I am one of the 5 guys who meets one of those 1,347, the math does not help me much. Gene's crew came together at Fort Knox in April of 1944. Driver Corporal James Jimmy Duchesne from Louisiana, Gunner Corporal Frank Kozlowski from Chicago, Loader Private Eddie Martinez, and Bow Gunner Private Robert Lee from Alabama. They trained together for 8 weeks, learning to operate as a single organism inside 9 meters of riveted steel. The Sherman was not a comfortable machine. Interior temperature regularly exceeded 120 degrees Fahrenheit in summer. The driver and bow gunner sat in the hull, separated from the turret crew by the rotating floor mechanism. The commander, gunner, and loader worked in the turret, a space roughly 2 meters in diameter, surrounded by ammunition racks containing 71 75mm shells and 6,300 rounds of 30 caliber machine gun ammunition. One German anti-tank round penetrating that space would detonate the ammunition and incinerate the crew in seconds. American tankers called it brewing up, and it happened often enough that some crews refused to load the ammunition sponsons on the turret sides, preferring reduced combat capability to reduced survival time. They landed on Omaha Beach on June 15, 1944, 9 days after D-Day. Their Sherman, serial number 3056893, received its name Boilermaker, painted in white letters on the turret side. Gene never discovered who started the tradition of naming tanks, but he appreciated it. If you were going to die in a steel box, it seemed proper that the box should have a name, an identity, something beyond a serial number. The first 3 weeks in Normandy taught them about bocage, the ancient Norman hedgerows that turned every field into a separate fortress. Dense earthen walls 4 to 6 feet high, topped with centuries-old hawthorn and bramble, created natural tank obstacles every 100 meters. The Sherman's narrow tracks 16.5 inches wide provided less ground pressure than wider German tracks, but they also meant less traction in mud. And Normandy in June was mud, rain, more mud, and occasional moments of visibility that made you wish for the obscuring rain again. They learned that German Panzerfaust anti-tank rockets could be fired from hedgerows you could not see until the rocket had already left its tube. They learned that the distinctive sound of a German tank engine, the deep, throaty rumble of a Maybach HL 230, caused involuntary fear responses, even in experienced crews. They learned to identify the different German tanks by sound alone. The higher-pitched whine of a Panzer IV's Maybach HL 120, the deeper growl of a Panther's HL 230, and the unmistakable bass rumble of a Tiger's Maybach HL 210 or 230, depending on the model. You heard a Tiger before you saw it, and that sound meant you had perhaps seconds to decide whether to engage, retreat, or call for artillery support. On July 24, 1944, 2 days before their encounter, Gene's platoon received a tactical briefing about German armour doctrine from a British liaison officer, Major Andrew Witherspoon, who had fought against German heavy armour in North Africa. Jean recorded the key points in his commander's notebook. Witherspoon had explained, "The Germans use their heavy armor as mobile pillboxes. They do not maneuver like we do. A Tiger or Panther will find a good position, preferably hull down, with only the turret visible, and wait for you to come to them. They have the range and penetration to kill you before you can hurt them. Their doctrine is simple. Let the enemy make mistakes, then punish those mistakes with superior firepower." Someone had asked about the Tiger's rate of fire. Witherspoon had consulted his notes and said, "The 88mm Hellcat 36 gun has a maximum rate of fire of 6 to 8 rounds per minute under ideal conditions. In combat, sustained rate is 4 to 6 rounds. The gun is exceptional, but every time they fire, there is a reload cycle. The spent shell casing must be extracted, a new round loaded from the hull or turret racks, the gun relayed on target. The Tiger's crew is highly trained, but they are still bound by physics and mechanical procedure." Another voice had asked, "What is our rate of fire, sir?" Witherspoon had smiled without humour. 15 to 20 rounds per minute with a properly trained crew. You are throwing 3 times the volume of fire. But here is the tactical complication: your rounds do not penetrate their frontal armour at combat ranges, and theirs penetrate yours from any angle. So you find yourselves in a rather interesting situation. Jean remembered the uncomfortable laughter that followed. Interesting was the British way of describing situations that would get you killed, but the rate of fire number stuck in his mind. 15 to 20 rounds per minute. That meant 1 round every 3 to 4 seconds. The Tiger fired once every 10 to 15 seconds. 3 to 1. 4 to 1. 5 to 1. The advantage seemed theoretical, academic, and meaningless when Tiger crews were killing Shermans from ranges where the Sherman's gun could not even reach them. But mathematics has a way of becoming relevant when circumstances change, when distance closes, when desperation demands calculation. What Jean and his crew did not yet understand, what no one in American armoured doctrine had yet fully articulated, was that rate of fire was not just about volume. It was about tempo, about rhythm, about controlling the pace of engagement and forcing your enemy to operate within your cycle instead of his own. The Tiger's 8 to 10 second reload cycle was a window of vulnerability, a gap in time when the most powerful tank on the battlefield became temporarily impotent. If one Sherman could fire twice in that window, the Tiger still had an overwhelming advantage. But if 3 Shermans could fire 6 or 7 times in that window, if each impact created vibration, noise, stress, and visual obstruction, then the mathematics began to shift. Not in favour of penetration, the Sherman's 75mm gun still could not punch through the Tiger's frontal armour, but in favour of disruption. And disruption, Jean would learn in 37 seconds of combat, was its own form of advantage. The morning of July 26th began with fog, which was both blessing and curse. The fog concealed movement but also concealed threats. Charlie Company, 2nd Armoured Division, was tasked with clearing a corridor south of the village of Le Desert as part of Operation Cobra, the American breakout from the Normandy hedgerows. 5 Shermans in a loose line formation, standard doctrine for open terrain where visibility might suddenly improve. Jean's position was second from the left. Lieutenant Morrison commanded the leftmost tank. Sergeant Kelly was to Jean's right, then Sergeant Rawlings, then Sergeant DiPietro anchoring the right flank. 5 tanks, 25 men, moving at 15 kilometers per hour across fields that had been Norman farmland until the invasion turned them into contested ground. The fog burned off at 0845 hours. Visibility improved to 1,000 meters, which meant they could see threats and threats could see them. Jimmy Duchesne's voice crackled through the intercom from his driver's position. Movement, tree line, 11 o'clock. Jean swung his periscope left and saw it immediately. Just the barrel at first, protruding from behind a collapsed stone farmhouse about 800 meters distant. Then the massive turret, rotating slowly. Then the hull, unmistakable in its boxiness, in the way it seemed to squat heavily on its interleaved road wheels. Tiger Eye. Jean felt his heart rate accelerate, felt the familiar adrenaline surge that training had taught him to channel into procedure. He keyed the company radio net, all Cobra units, Tiger, 11 o'clock, 800 meters, hull down position. Kelly, Rawlings, DiPietro spread right, flank speed. We are closing distance. The Tiger fired first. This was expected, doctrine, the inevitable outcome of the range equation. Later, Jean would learn that Oberleutnant Klaus Müller commanded that Tiger, part of Schwer Panzerabteilung 101, the 101st Heavy Tank Battalion. Müller was 28 years old, a veteran of the Eastern Front with 17 confirmed tank kills. His gunner, Unteroffizier Otto Brandt, had trained at the Wehrmacht's elite Putlos gunnery school and could hit a moving target at 1,500 meters. Brandt's first shot was textbook perfect. The 88mm armor-piercing round struck Lieutenant Morrison's Sherman, precisely at the turret ring, the junction between the rotating turret and the stationary hull. This was a weak point in the Sherman's design, a necessary gap to allow turret rotation, protected by only thin, overlapping armor plates. The round penetrated completely. The Sherman's ammunition, stored in the turret sponsons, detonated. Morrison and his 4 crew members died before they could register pain. The Sherman became a fireball, black smoke pouring skyward, visible for kilometers. Jean's training overrode conscious thought. His voice came out calm, procedural, exactly as Fort Knox had drilled into him. Full speed ahead. Gunner, target Tiger, fire at will. Eddie, keep feeding. The 450 horsepower driving 30 tons of tank at a top speed of 38 kilometers per hour on open ground. The ride was violent, the suspension barely adequate for the terrain, but speed was survival. Range was dead. 7 seconds after the first shot, the Tiger fired. Again. Sergeant Kelly's Sherman took the round through the front glacis plate, the sloped frontal armor that was the Sherman's best protection. The round did not fully penetrate, the angle was steep enough to cause deflection, but the kinetic force of an 88mm projectile, travelling at 800 meters per second, did not need penetration to cause damage. The impact broke Kelly's right ankle, where it rested against the radio mount. It also started a fire in the engine compartment, and Kelly's driver immediately executed emergency shutdown procedures. Kelly's crew bailed out through the hatches, tumbling onto French soil while their tank burned behind them. 2 tanks destroyed or disabled, 10 men killed or wounded, 14 seconds of combat. Jean's Sherman was now 650 meters from the Tiger and closing at maximum speed. Kozlowski, the gunner, fired their first round without being told. The 75mm M61 armor-piercing shot struck the Tiger's frontal armor and ricocheted into the sky, doing no damage whatsoever. The Tiger's frontal armor was 100mm thick at the hull, 120mm at the turret. The Sherman's 75mm gun could not penetrate that thickness at any combat range from any angle. This was known. This was the mathematics that made Tiger crews confident and Sherman crews desperate. And then Eddie Martinez said it, his voice tight but certain through the intercom. "Sarge, we're faster than him." Jean understood immediately. The comprehension arriving fully formed as if it had always been there, waiting for crisis to reveal it. The Tiger's gun was devastating, overwhelming, superior in every measurable way. But between each shot came the reload cycle, 8 to 10 seconds. In that window, the Tiger was just a steel box with thick armor. In that window, it could not hurt you. And in that window, a Sherman crew could fire twice, maybe 3 times. And if you too had not 1 Sherman but 3 or 4, all firing continuously, all hitting the Tiger with rounds that did not penetrate but did create shock, vibration, noise, fear. Then those 8 to 10 seconds became an eternity for the Tiger crew. They became a window of vulnerability that American doctrine had never properly exploited, because American doctrine had focused on the wrong variable. It had focused on penetration when it should have focused on tempo. Gene keyed the company net, his voice loud and clear. "All Cobras, continuous fire. Do not aim for weak points. Just keep hitting him. We are his reload time now, close and flank." What happened next lasted 37 seconds. Gene would later reconstruct the timeline from after-action reports, crew interviews, and his own commander's log, which he had trained himself to update even during combat. The chronology was precise, each second documented. 0849 hours, 22 seconds. Tiger fires third shot. The round misses Sergeant Rawlings Sherman by 2 meters, creating a crater 6 meters in diameter in the Norman soil. 0849. 25 seconds, Gene's Sherman fires round number 2. Impact point. Tiger's gun mantlet, the thick armoured shield protecting the turret front where the gun barrel protrudes. No penetration, but the Tiger's commander, visible in his open cupola, flinches from the impact shock transmitted through the entire turret structure. 0849, 27 seconds. Sergeant DiPietro's Sherman fires. Impact point. Tiger's cupola. No penetration. But the Tiger commander drops down into the turret and closes his hatch, reducing his situational awareness. 0849. 29 seconds. Rawlings fires. Impact point. Tiger's right track guard. No damage, but noise and vibration continue. 0849. 31 seconds. Gene's Sherman fires round number 3. The distance is now 450 meters. Impact point. Tigers. Turret front, left side. A bright orange spark marks the ricochet. 0849. 33 seconds. DiPietro fires again. Impact point. Tiger's turret side, though the angle is still too oblique for penetration. 0849. 34 seconds. Tiger fires fourth shot. The round hits Rawlings Sherman in the engine compartment. The Sherman does not explode, but the engine is destroyed. Rawlings' crew begins emergency evacuation, but they are alive, functional, 3 men intact. 0849, 36 seconds. Gene's Sherman fires round number 4. Distance, 400 meters. The chaos is total now, 3 Shermans firing, moving, creating dust and smoke, the Tiger rotating its turret to track multiple targets. 0849, 38 seconds. DiPietro fires. The impact creates another bright flash on the Tiger's armor. 0849, 40 seconds. Gene's Sherman fires round number 5. Distance, 370 meters. The Tiger is still trying to track DiPietro's Sherman, which has just crossed the Tiger's frontal arc and is moving to the right flank. 0849, 42 seconds. Kozlovsky, Gene's gunner, suddenly screams through the intercom, "Target left! Target left!" Gene looks through his periscope and understands instantly. The Sherman's speed and maneuver has carried them past the Tiger's frontal arc. The Tiger's side armor is now visible at a 65-degree angle, 340 meters away. The mathematics have changed. The Tiger's side hull armor is only 80 millimeters thick. The Sherman's 75 millimeter gun can penetrate 80 millimeters at 300 meters. 0849, 45 seconds. Kozlovsky fires round number 6 without waiting for orders. The M61 armor-piercing round travels the 340 meters in less than half a second. Impact point. Tiger's right side hull, below the turret ring, above the first road wheel. Penetration complete. The round punches through 80 millimeters of steel and detonates inside the crew compartment. The Tiger's own ammunition begins to cook off secondary explosions, white-hot flames, black smoke pouring from every hatch and vision port. 0849, 59 seconds. Engagement complete. Total elapsed time. 37 seconds from first Sherman shot to killing blow. Jean's Sherman skidded to a halt 30 meters beyond the burning Tiger. Jimmy Duchesne cut the engine. The sudden silence was profound, broken only by the crackle of flames and the sporadic pop of small arms ammunition cooking off inside the Tiger's hull. Jean climbed out of his commander's hatch, his hands shaking, his ears ringing from the gun reports in the confined turret space. Eddie Martinez followed, sat on the turret exterior, and lit a cigarette with trembling fingers. DiPietro's Sherman stopped to their right, its crew also emerging, also shaking, also alive. "How many rounds? Did we fire?" Jean asked. His voice sounded distant, muffled by temporary hearing loss. Eddie checked the ready rack inside the turret. 6, maybe 30 seconds of actual shooting. 6 rounds in 30 seconds. The Tiger had fired 4 rounds in the same time period. But those 4 rounds had been aimed, deliberate, lethal. They had killed Lieutenant Morrison's entire crew and disabled 2 other Shermans. The Shermans had fired continuously, rapidly, creating chaos rather than precision. And that chaos had bought time. Time to close distance, time to flank, time to find the angle where the Sherman's gun could do what the Tiger's armor could not prevent. 3 men emerged from the Tiger's hatches before the internal fire became too intense. The driver, the loader, and the radio operator. They were burned, coughing, and stumbling. Oberleutnant Müller and his gunner Brandt died inside, killed by the penetrating round or the secondary explosions. The 3 survivors collapsed on the ground. Jean and DiPietro's crews provided first aid, water, and basic treatment for burns. The German driver was 19 years old. The loader was 20. The radio operator was 18. They looked like American teenagers. They looked like Eddie Martinez, Jimmy Duchesne, and Robert Lee. They looked exactly like what they were. Young men trained to operate a machine, now prisoners, now alive only because Jean's crew had fired faster than their crew could reload. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Jean recorded his thoughts that evening in his commander's journal, dated July 26, 1944, written by candlelight in a Norman barn that C Company had commandeered for the night. The entry read, "We killed a tiger today, not through superior tactics or better equipment, but through desperation and mathematics. Morrison and Kelly died because we could not close distance fast enough to matter. But once we were close, once we were moving, once all 3 surviving tanks were firing continuously, the Tiger crew could not operate their superior weapon effectively. Every impact, even non-penetrating, created noise, vibration, fear. Brandt, their gunner, could not aim carefully while his tank was being hammered by shells every 3 seconds. Müller could not command effectively while his cupola was being hit. They lost not because their tank was inferior, but because we did not give them time to use their tank's superiority. Eddie noticed it first. We are faster than him. Not faster in speed, the Tiger is not mobile. Faster in rate of fire. And rate of fire, we discovered, is a form of suppression. We suppressed the most powerful tank on the battlefield using weapons that could not hurt it, and that suppression bought us the seconds we needed to flank and kill. The after-action report, filed by Captain James Walsh on July 28, 1944, formalized Jean's observation into tactical doctrine. Walsh wrote, Engagement with PZAR, KPFW, VI ORSF. Tiger 1 demonstrated effectiveness of concentrated fire and rapid maneuver against stationary heavy armor. The enemy tank fired 4 rounds in approximately 37 seconds, average cycle time 8.7 to 5 seconds. 5 M4 tanks fired a combined estimated 18 to 22 rounds in the same period. Average cycle time 1.6 to 2.0 to 5 seconds per tank. While individual M4 rounds were ineffective against enemy frontal armor, cumulative effect created sufficient disruption to degrade enemy gunnery effectiveness and enable successful flanking maneuver. Recommend, when engaging superior armor at range, Multiple units should maintain continuous fire to suppress enemy while maneuvering elements close distance and seek favorable angle of engagement. The tactical concept spread rapidly through the 2nd Armored Division and then to other American armored units in Normandy. Jean's company commander, Major Robert Stiles, circulated a memorandum to all tank commanders in the regiment on August 3, 1944. Jean kept a copy, folded in his journal. Rate of fire is a weapon. When engaging superior enemy armor, do not wait for perfect shots. Maintain continuous fire. Force the enemy to operate under impact stress. Each hit, even non-penetrating, creates vibration, obscures vision ports, degrades gun-laying accuracy. A tiger or panther that cannot aim carefully is a tiger or panther you can flank. Exploit reload cycles. The enemy fires once. You fire 3 or 4 times. Use that tempo advantage to maneuver. This is not about destroying enemy armor with frontal fire. This is about suppressing enemy armor long enough to achieve positional advantage. The doctrine had a name by September. Fire superiority through volume and tempo. It was not revolutionary. It was mathematical, obvious in retrospect, the kind of tactical insight that seems simple only after someone discovers it under pressure. But it worked. Combat reports from September through December of 1944 repeatedly mentioned similar tactics. Multiple Shermans engaging heavy German armor simultaneously, maintaining continuous fire, exploiting reload cycles, using rate of fire advantage to create windows for maneuver. But Jean never saw it as doctrine or discovery. In his personal journal entry from July 27th, he wrote, "We did not invent anything. We got desperate. Morrison and Kelly died, and we started shooting because shooting was all we could do. Eddie noticed the rhythm because he was the one ramming shells, so he lived in those 3-second cycles. I think we stumbled onto something that was always mathematically true. We just never thought about it because we were too focused on penetration tables and armor thickness. We thought the Sherman was inferior because its gun could not match the Tiger's gun. But warfare is not gun versus gun. It is system versus system, crew versus crew, tempo versus tempo. And in that equation, the Sherman had advantages we did not recognize until we needed them to survive. The cost of that discovery was high. Lieutenant Morrison's crew, 5 men dead. Sergeant Kelly's crew, 1 man wounded seriously, the others treated for burns and shock. Sergeant Rawlings' crew, engine destroyed, but the crew survived. Against that, 1 Tiger destroyed, 2 crew killed, 3 captured. On paper, the Germans won the exchange. Tigers cost more, were harder to replace, represented greater industrial investment. But Jean's crew was alive. Di Pietro's crew was alive. Morrison's crew was not. The mathematics of victory and loss, Jean realized, could not be calculated in production costs or replacement rates. They could only be calculated in names, in faces, in men who would return home or men who would not. Jean Moffat survived the war. So did Eddie, Martinez, Jimmy Duchesne, and Frank Kozlowski. Private Robert Lee, the bow gunner, died near the German border in January of 1945, killed by German artillery fire during the Battle of the Bulge. The crew attended his funeral together in Alabama in June of 1945, standing in their dress uniforms while Lee's mother accepted the folded flag. Jean remembered thinking that Lee had survived the Tiger, survived Normandy, survived 4 months of combat, only to die in the final months of the war. The randomness of it seemed obscene, unjust, a violation of some unspoken rule that surviving the worst should protect you from lesser dangers. But war had no such rules. War had only mathematics and chance respected neither skill nor luck. Jean returned to Purdue University in September of 1945 and completed his interrupted graduate studies. He became a professor of mechanical engineering, teaching at the same institution where he had studied before the war. He taught courses on systems analysis, structural mechanics, and beginning in 1958, a seminar on military technology that included a lecture about his Tiger encounter. One of his students, Robert Gilson, recorded a portion of that lecture in 1973. The lesson was not about tanks, Gene told his students. It was about time. Every system has a cycle time, reload time, reset time, processing time, recovery time. If you can operate inside your opponent's cycle, if you can force them to react while they are still recovering from the last action, you create advantage from what appears to be disadvantage. We were not better than the Tiger crew. We were not braver or more skilled. We were faster. We could shoot 3 times in the time they needed to shoot once. And that speed, that tempo, that rhythm, it created windows of vulnerability in what seemed like an invulnerable system. This applies to engineering, to business, to any competitive system. Find the cycle time. Find the reload gap. Exploit it. Gene donated his service pistol, his commander's periscope, and his personal journals to the National Armor and Cavalry Museum in 1985. When asked why, he said, "So people remember that wars are solved by men who figure things out under pressure, not by the men who drew the original plans." He died in 2003 at age 84. His funeral was attended by the surviving members of his crew and their families. Eddie Martinez gave the eulogy and said something that captured the essence of that July morning in Normandy. "Gene taught me that being outgunned does not mean being beaten. It just means you have to think differently." The Tiger crew that day did everything right. They were trained, professional, and skilled. But we were faster, and those 37 seconds made all the difference. The Sherman's rate of fire advantage over German heavy armor became institutionalized in American tank doctrine. The principle that sustained fire rate matters as much as per-round lethality influenced post-war tank design across all nations. The M26 Pershing, which replaced the Sherman in the final months of the war, maintained a high rate of fire despite having a larger 90mm gun. The M46, M47, M48, and M60 series that followed continued to prioritize reload speed and fire control systems that enabled rapid engagement of multiple targets. The modern M1 Abrams can fire 8 to 10 aimed rounds per minute with its 120mm main gun, not because each round is more powerful than competing designs, but because American doctrine recognizes that time between shots is vulnerability, and vulnerability is opportunity for the enemy. The Tiger I was a remarkable machine. 100 tons of production effort produced one of the most powerful tanks of the Second World War. Its 88mm gun could penetrate any Allied tank from any angle at any combat range. Its armor could defeat most Allied anti-tank weapons, but it could fire at best 6 aimed rounds per minute. And those 8 to 10 seconds between shots, that reload gap, became the window through which Sherman crews learned to attack, not with superior firepower, but with superior tempo. Not by hitting harder, but by hitting more often, creating chaos and suppression that turned mathematical inferiority into tactical advantage. The broader lesson extended beyond tanks and beyond war. Complex systems, technological, organizational, human, all have cycle times, rhythm, tempo. The system that appears invulnerable often has hidden gaps in its operational cycle. The enemy that seems overwhelming may have a reload time you can exploit. Power without sustainability is vulnerability. Lethality without rapid delivery is an opportunity for the opponent. These were the lessons that Gene Moffat learned in 37 seconds on a Norman field in July of 1944, and they were the lessons he taught to engineering students for 40 years afterward. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.